So, good morning or good afternoon, wherever you are at. Thanks for joining the CAR Strategy and Policy Pacing call. We have a call document link. So, if you could please sign into the call doc, that would be great. We are recording this call, and the recording will be posted to the YouTube site. So, if you are not comfortable with that, uh, please feel free to leave the call at this point. I think our instructions for all the calls that we are conducting is to give like a fairly long enough break for people to decide and leave. Um, will the chat be recorded and posted? No, the chat does not get posted anywhere. Uh, we do take the chat comments and put it in the call doc. If they're sent to everyone, unless it's an individual exchange, that doesn't get recorded either. All right, so I think folks are okay with the recording piece. So, and then we have CARC has a code of conduct. So you can look it up on the link to that is in the call doc. So if you have not seen the call doc, then please sign into the call doc and look at the code of conduct. I will do a quick brief review of what CARC is for folks who might be joining in for the first time. I'm going to do a quick share of my screen. You guys see my screen?
Yes, we can see it
All
now.
right, thanks. All right, so CARC is Campus Research Computing Consortium. So basically, it's an organization of research computing and data professionals. Actually, the term RCD is coined by the CARC community, and it's now being used pretty much everywhere. So CARC has like different parts to it. The biggest part is like the People Network, which is an annual ongoing conference that has sessions every month. There are various tracks. We are part of the strategy and policy pacing track. You can look up other tracks on the CARC website listed at the bottom left, carc.org. There are other groups, also working groups, interest groups that are topic specific focused. And then the operations group is supporting the logistics of CARC. So this is the strategy and policy pacing track steering committee. Um, we are always This is the committee that kind of sets up the agenda. So we are always looking for new people to join the steering committee, and I'm currently actively looking for someone to be the co-coordinator on the steering committee. So if you are interested, just send a note to me, and I'll be happy to have you onboarded. So quick announcement for the next month. We are going to talk about the CASC meeting, the CNI meeting, the RDAP meeting, and the NAIR pilot annual meeting that happened like I think a couple of weeks ago. So the recap of all these meetings, because most oftentimes folks don't get to go to all the meetings. So we'll have a recap and discussion around that. So hopefully you'll be able to hear on that in the April call. And for today's call, we are going to talk about the data problem. So for that, we have two speakers, Curt Hillegas from Princeton University and Scott Yockel from uh, Harvard University. And Scott is also part of the Northeast Storage Exchange. So he's going to touch on both of those aspects. So the format kind of is both the speakers will do talk about their solutions, what the challenge that they are trying to solve with the data problem, how, how
Hello?
they are solving it, and then what their future vision looks like. So uh, the format is like I
Yeah,
don't
you try
know,
to code. The last name is SFEN or
sorry. I'm guessing Kurt and Scott, you both have some slides to share. So they'll do a brief presentation, and then once the presentation then is done, we'll have open discussion. So you can throw your questions in the chat, but we rather prefer you throw those into the call doc. So with that, I'm going to turn it over to, I don't know, Kurt or Scott, who wants to go first?
I'll
Either
let
one.
Curt go first.
All right,
I'm happy to go first.
take it away. So, Curt Hillegas is Kurt. I don't have your official title, but you are AB, like Associate Vice President for Research and Data, right? Like,
Actually, now Senior Associate
oh,
Dean.
Senior Associate Dean. Okay. Yeah. So,
Is my slide showing in presentation mode?
Yes, we see it.
yes. Thanks.
Awesome. Very good. So probably about 6 or 7 years ago, the Dean for Research, the CIO, and the librarian at Princeton University got together and determined with all of the requirements around publication of research data, they created what was called the Princeton Research Data Service. It's still called the Princeton Research Data Service, really aimed at publishing that data at the end of a project, making it public for the general research community. And it's a great idea. It's been very successful. We've got a repository that people put their data in, but very quickly we realized that's the tip of the iceberg. There's all this other data that's being worked with. It may be, actively worked on data that would be in Scratch, but there's this huge massive data that's needs to be kept, that's still active, may be shared with other people. And so we started a project which is developed into a service, and that project or service is aimed at changing Princeton University from having a data storage philosophy or data storage culture to having a data management culture. And so this is really, you'll see there's a huge amount of storage associated with Tiger data, but the real focus is to make it so that we're not publishing data at the end and doing all of the curation and description and everything at the very end. The idea is start describing that data even before it gets produced, and then tracking its lifetime all the way through. When you can, heaven forbid, get to throw data out, or when to publish it. How the curation process for publishing then becomes much easier. And some data never gets published or thrown out, but it gets stored and it can be moved to the appropriate location for each stage of its life cycle. So I'm going to show this slide just very briefly, just because people often have a misconception about Princeton. Princeton is actually a fairly small university with a big footprint. So we have 1,300 faculty. About 78% of those faculty are tenure track. Over the years, we've had 32 Nobel Prize winners. 1,700 research funding awards currently, and we have about a total of 9,000 students. 5,700 of those are undergraduates, and 3,200 of those are graduate students. We do not have big professional schools. So that's what makes Princeton kind of really small, is that we don't have a medical school, a law school, a business school. We have the college, we have the School of Engineering and Applied Sciences, and we have the School of Architecture, the graduate school, and it's all very compact and small. So that's why I'm showing this slide. I do have to apologize to Scott. He asked if I was having slides. I said, yeah, no more than 3 to 5. I actually have 8 slides, but I added some of them just to make little points like that. So what do we want to create with Tiger data? We want to create something that has kind of on the technical side, the capacity, reliability, functionality, and performance that the researchers may be looking at. And on the other side, we want the researchers to be able to describe, tag, seamlessly move, easily find and reuse and share their data with collaborators. So there we're talking about the FAIR principles. So I will just briefly read the vision for Tiger Data, which has just been updated. I also have the mission here, but that's a little bit too long, so I'll just read the vision. So the vision is that, oh, I have to reload this, sorry. I may not be reading there we go. The vision is that the Princeton community relies on Tiger Data for the necessary tools, infrastructure, and expertise to manage their data effectively and securely at scale, advancing the long-term sustainability of research and institutional data, facilitating collaboration, and promoting the preservation and reusability of data and code. So how do we get there? So this is a kind of the large ecosystem at Princeton of research and data storage. So you can see over on the left, I show research computing, specifically our researcher engagement area, where this is where we have contact with researchers directly. And the library also has the Princeton Research Data Service. Up in the upper left corner is research computing's infrastructure. We have a Citadel, which is a secure research enclave. We have a whole bunch of scratch storage on our clusters. We also have a large GPFS file system attached to our clusters that hopefully will be going away over time. And then we have Tiger Data, which is kind of alluded to in this upper right-hand corner, where we're using MediaFlux, and Princeton Research Computing is really kind of bringing together the infrastructure to build Tiger Data. At the bottom, you can see other storage. Academic departments have storage. The Princeton University Library has storage systems. OIT, the Office of Information Technology, offers them. So there's a collection of data storage at the university. And we're trying to unify this and make it easy for people to decide where and how to store their data and how to manage it. This is one there again, Scott. This is kind of two slides that are separated as really one idea. This is showing that Tiger Data is a broad team. These different colors represent different departments. We have the library, we have the Office of Information Technology. We actually have multiple areas in the library, and then research computing is over on the right. And the next slide shows a little bit more of a kind of the direct organization chart for Tiger Data. So under me, Beth Holtz reports to me. She's the Senior Director for Advanced Data and Storage Management, and she has a team that really manages the hardware infrastructure as well as MediaFlux, which is the middleware that is used to manage the data. It provides indexing, metadata management, and such. It also presents the data out via the standard protocols, NSF, SMB. It has the capability of HTTPS and S3. We have not implemented those last two yet. And then on the left side, you can see the library teams. There are three areas of the library. Matt Chandler and Hallie Burns are actively engaged in the data management and developing a community of practice around data management. So the library will not be doing all the data management for this data. They'll be training data managers that are embedded in academic departments and even into research groups to help their colleagues to manage the data in the projects and in their departments. And then Kate Lynch and her team are a software development team, a bunch of software engineers, and they're developing a web front end to MediaFlux that's going to help people to manage their data, see what they have, not accessing their data like they would with NFS, but being able to see what's in there, how much they have, change some of the metadata and such. And then at the bottom, Dan Chin is with the OIT Enterprise Infrastructure Services Group, and Steph Ayers is the Associate Director of IT for the University Library. So all of us work together to provide the infrastructure and then all the services that go around Tiger Data. So this is kind of a view of what Tiger Data looks like. You can see that it's driven, we've got MediaFlux all over here. MediaFlux is a piece of middleware published by, that we purchased from Architecta, which is an Australian company. MediaFlux surprisingly was designed to manage media files for studios and such, but it has a strong schema for managing the metadata around data. It also, as I said, provides the protocol engine, NFS, SMB, and SFTP right now. We're also using Globus for data movement as well. We've got authentication, authorization. So MediaFlux is managing kind of this central piece, what you would think of middleware. At the bottom, you can see the storage systems we have. We have what everyone refers to as an Isilon NAS, which is 24 petabytes right now. We have an IBM Cloud Object Store, which is 20 petabytes, and a Dell Elastic Cloud Storage, which is 20 petabytes. So we have about 75 petabytes of active storage available on Tiger Data right now. And we just purchased a, just got a phone call. We just purchased a tape library, actually four racks of tape library, 127 petabytes to back up all of Tiger Data plus some other things at the university. And then you can see this gray box over on the left. This is some of the data that's outside of Tiger Data. Some of that is actually being managed a bit by MediaFlux as well. We're doing some indexing, and we can do some tagging of data outside of using MediaFlux in its out-of-band perspective, which means that it's not actually managing the storage, but it can manage some of the metadata around the storage. And finally, I'll just say that we're seeing very rapid growth of Tiger Data. The top plot shows the number of projects. Over the past year, they've grown from about 20 projects up to 70 projects. And the bottom chart shows the quota allocation, which we've allocated about 14 petabytes of the storage, and currently about 7.5 petabytes is being used. And you can see that very large number of assets that we have at the bottom, 500 million assets, which I'm sure will grow to billions in short order. And for me, that's the end of the story.
All right, thanks, Curt. We will put the questions, we'll take the questions, I guess, after Scott is done. So Scott, you can go ahead. Thank you.
Okay. I was moving it from one screen to the next. There. Okay. So very similar conceptually, I think, to what Curt just talked about, Tiger Data at Harvard. You may have heard us talk once before about Harvard Data Commons, but the Data Commons term is, I think, overused and confusing because there's also people at Harvard that are part of the Google Data Commons or the NIH work on Data Commons. So we rebranded it as the Harvard Research Data Connect. I think one of the things I wanted to point out just in the title slide here is that this is truly a collaboration, I think like Curt mentioned, but like between the libraries, Library IT, which is kind of a split report, with, and also with the OBPR. So also on the call today with me is Yuan Lee, who Curt knows well because she used to be at Princeton. She's our University Scholarly Communication Officer. So she's kind of like my counterpart in the library, whereas I focus on the research computing. And then my counterpart who's in the OBPR office is Emery Keskin. Is the AVP there for research data strategy. So the three of us work together a lot and think about, and we're all in central administration. So we think about like, what are the services and things that we can do centrally, and then how do we partner with the schools? Because the school at Harvard, the schools are where a lot of the research computing services exist. There's also school libraries that have, very domain specific areas and stuff like that. So there's a lot of different branches of places for us to connect. So each of us try to do that in our own domain. So like Yuan in the library, Emery with sponsored programs and stuff, and I do it in research computing. So I just kind of wanted to point that out. So this is kind of just the general question that we ask ourselves every time we think about talking to researchers. I think Curt kind of mentioned this too, but like, what challenges are you, facing in sharing and publishing data? What technology or tools would you like to see? Because right now, in the past, researchers are using different tools upon different stages of the life cycle of data, right? So in the planning stage or the storing data, they acquire data and then they do analysis on it. And then later, after they go to publish, they publish the data. We hope they do. They use data repositories to store it in, also within open access journals and stuff like that. And then also disposal is a part of this. So each of those stages right now, for the most part, people are using different sets of tools, and the tools don't talk to each other, right? They're not interoperable. So that's kind of our view of what Harvard Research Data Connect is. And I'll also point out that a lot of times each of these stages also involves different groups of people on campus, different staff, different services that they're getting these from. So the goal is to really make it easy in a large organization like Harvard for a person to understand who to connect with, right? How to do things in large volumes of data, how to make it reproducible, right? How do we set up best practices and then also provide the tooling that helps aid in the sharing, support retention for compliance reasons, like we have like the NIH data sharing. The provenance of data is really important. And then also we need metrics as an institution so we can make informed decisions on planning for data and think about data as an asset, which really hasn't been done in the digital space like it has been done in the physical space in the library. So I'm going to pass this off to Yuan maybe to cover this next few slides.
Thank you, Scott. Thank you for the introduction. And I also wanted to extend the thanks to Patrick for inviting us. So I'm part of, as Scott introduced, I'm part of the HRDC leadership team, and then it's my great pleasure to talk about a little bit about HRDC. So our vision for HRDC is to create an ecosystem that connects researchers with computing infrastructure, commonly used software, services, tools, and applications for finding, accessing, managing, analyzing, and sharing data. So basically, we're saying we wanted to create a portal, right? And we want to make research process easier, so they can come here at one place and then they can find what they need. They can find the person that they need help with, and they don't have to go around the campus. Even sometimes they don't know those tools, those services are available. So really, we want to emphasize the connect part. So importantly, right, HRDC aims to connect in both strategic ways. So one is to connect the researchers with the staff, so that we wanted to ensure they can get necessary guidance or help them navigate this complexities of the research data process lifecycle. And then we wanted to bridging staff to staff across campus so that those subject matter experts can also work together more effectively and can share knowledge. So as we build HRDC, we are committed to a set of guiding principles that ensure we create a sustainable and effective ecosystem. So first, we wanted to make sure we treat research data as asset. We must manage it at a scale and ensure the long-term preservation. Harvard is big and then very distributed, so we want to make sure collaboration is a key here. And we foster a collaboration among different units on campus, including library, research computing, local school computing, as well as local schools. We wanted to create the framework that seamlessly integrate research management tools and computing resources. We also wanted to build for reusability. Where possible, we'd like to work with our peers to create the tools and the guidelines that can be shared and repurposed beyond Harvard. And lastly, but definitely not least, we want to align with the FAIR principles that improving the findability, accessibility, interoperability, and reuse of our digital assets. So how do we turn this vision into reality? HRDC is being built through a phased approach, starting with these three objectives. So first, we want to conduct a discovery phase. We wanted to understand better what exactly our research and administrator leaders, deans needs, and to ensure the HRDC deliver the real value. And another objective we like to deliver is to enhancing access and discovery. We want to improve systems that allow researchers to find and use Harvard research output more effectively, and as well as other resources. And then the last one, again, it's integrated. We want to integrate computational workflows into the ecosystem. So such as those tools like Jupyter Notebook, RStudio, MATLAB scripts, and various data analysis tools to make HRDC a digital research ecosystem. Next slide, please. To ensure HRDC effectively address the challenges faced by campus, by researchers, by faculty, we kind of begin with a structured discovery phase, which we invite two external consultant to help us to do a comprehensive landscape review on across Harvard University. So this process include a review of existing materials, including some of the faculty interview we have done before, institutional policies, procedures, and available research data tools on campus. Another component is on-site and remote stakeholder interviews, including faculty, research computing staff, research facilitators, and administrative leaders, as well as librarians. The third part is the workshops with HRDC leadership team, and these workshops helped us define core user needs and strategic priorities for HRDC. Through this discovery process, some challenges at pinpoint got identified. The first one is issues in data and tool discovery. Harvard is huge, and then researchers struggle to locate where the available data sets are and who has them, and as well as other resources and services, trainings, like all these different resources scattered around on campus. Another challenge is in data management and access and sharing. So there's a lot of support existing in different part of a campus. But there's lack of a strategic planning and an institution culture around those services. So again, a lot of trainings, a lot of services existing somewhere around one corner of a campus, but was not kind of known or informed by other researchers, like two other researchers. It's kind of not visible to them, and they don't know where it exists. And also there's kind of no standard cross-campus training on how you better managing and sharing your data. It's really exists kind of a different part of a campus. As Scott notes, there's research computing in schools, there are also libraries in schools, and then sometimes those resources got kind of siloed. Another challenge and pinpoint is existing in research infrastructure challenges. That's including challenges in computing limitations, like research computing resource limitations, storage inefficiency, as well as the redundant efforts. School, they may doing the similar things, but they may not talk to each other. And then those local solutions often do not scale, kind of leading to some duplicated tools and fragmented support structures. And the last one is the funding and the services cost issue. Harvard using this distributed cost model. So basically, researcher has to pay for whatever they use, including computing resources, clouding services, storage. Sometimes the cost is very high, and then researchers kind of express the concerns over that. So that's for this discovery phase we have discovered.
Yeah, I think one thing I was going to touch on that you kind of mentioned, that Curt also mentioned, was the culture. So I think changing from a culture of kind of a siloed infrastructure, but also a culture of, so the siloed infrastructure meaning like that you can't move from one place to another. It's not, you can't just like go to another service that exists in another unit and then your data be present there, right? That's what I mean by like siloed infrastructure. That's like a real challenge. And then the culture of, I think like you described, Curt, where it was a culture of storage and it's not a culture of data management, right? And I think that's the other thing that became more and more obvious. And it's obvious throughout the whole data life cycle, is what I'm gonna say. So I mean, this slide just says that those three groups, the library, research computing, and the research office, really want to work together to try to help make this easier for researchers. And we have bits and pieces of, like, we're not as far along as Tiger Data is, I believe. And I think the other thing would be maybe a little bit different than what we're doing is we want to really include things like in the planning stage, like data management tool, electronic lab notebooks. We want these tools to integrate with the metadata that's created there into the data analysis phase and then on into the kind of publication phase. That's one of the things that we're really trying to work on. So I was just kind of mentioned there's a collection of tools that exists. So like DMP tool, part of the campus has RSpace. The medical school just switched to a different electronic lab notebook. I don't remember the name of the one they just switched to this year. But those exist. You know, there are definitely code repositories and computational notebooks. We have like an enterprise license for the university for like, you know, GitHub. There are Globus data transfer endpoints now within, I think, 9 different places on campus, including the libraries, as well as enterprise storage and enterprise IT, and then the research computing groups. And then in this end of publishing and archiving, of course, we have Harvard Dataverse. Dataverse integrates with a couple of these tools, and like Dash and the digital repository service. Dash is for the open access journals. So there's work like that that's been done, but there's not like the seamless tool chain of supporting the data lifecycle. And that's the thing that we're trying to figure out and come up with specific use cases and partner with specific schools to like start doing that work. That's kind of the next phase. Like, how do we get an end-to-end solution? And then we'll, of course, need to do some tooling between these different layers with some middleware. And I think the other big thing that you want to mention was like this portal. I think it's really important for us to think about a portal as a place for people to come to, and they could come there to search for data. They could come there to learn about programs, right, that exist, you know, services that exist, training. So we want it to be kind of a rich environment that is like just in time for a number of the different phases. So that's that. And then I have to switch gears and put on my NGHPCC hat, which I also have, and this will be just, I'll click through these really fast. It'll be maybe a few minutes. Keep covering up the presentation button. There we go. Okay, so I guess back in 2018, we started the Northeast Storage Exchange. It's really a regional collaboration at this point. And the whole driver was within the data center of NGHPCC, right? We have UMass, the whole UMass system, Harvard, MIT, Boston University, and MIT. That was back then. Now we also have Yale. So it's just more and more compute all the time. And so keeping up with data is a challenge. The Atlas project alone, we're starting to have conversations with them about what this run 4 will look like. And as you can see, this huge change in the amount of, and so we have both the Atlas and the CMS part of LHC in the data center. Both of them are the Northeast regional locations for it. This is the collaboration. These are the players. And then at the end, when I talk about, we have our own little strategy and policy group. This is mostly the participants of the group. This is transitioned out of the DIBS ward now and transitioned into a fully self-sustaining. And like Curt said earlier, these are the drivers, right? And this is the drivers for all of us. And we chose to build 2 services, a disk-based service, which is Ceph. So I was kind of caught off guard that we're already up to 52 petabytes of this Ceph service at this point. One of the largest ones that we know about is the one that CERN has, and it's not much larger than what we operate. And so the reason why it's cost effective is we operate all of that stuff with really just one FTE's worth of staff, because it's one huge system that supports all of these people. And it's secure and it provides bandwidth because it's an aggregate system. That's one of the things that's nice about it. And we also plan the network out to be performant as it's serving out and peering to all the different university networks. And then the tape provides us a nice longer term place to do data storage, and also much, much cheaper. So I was just going to mention a couple of points about the way in which we handle a regional storage with just such a small number of staff is that we do not provide this to end users. Mostly because there are multiple different identity providers, different networks, and all that. We provide it to research computing groups, right? So they are actually the user. So what happens is we have a set of data transfer nodes. It has Globus on it. And on the back end, we either have Ceph storage or we have Spectrum Scale, and we leverage Globus auth on the front end. So if we can create a guest, or we can create a managed collection, sorry, it's changed names so many times. Used to be called, a guest share. Anyways, we can create that for an owner of the media, and then they can then delegate, we can delegate control, and then they can add users. So they can manage users, they can create folders, they can do all that actually through the Globus interface, whether it sits on the Spectrum Scale GPFS or it sits on top of CephOS. And then users can interact with it either through the command line if they want to automate it, or if they can interact with the GUI. So it's a really nice way to scale out a whole lot of storage resources without having to scale out support. And then the other thing we also do on the Ceph side is inside the data center, we can also replace somebody's SAN or their NAS and provide them right with block storage. One comment I will say is to transition from the grant funded to what is sustainable fee for service, we had to come up with some very clear understanding of, I've mentioned this already before, like we have the concept that there's a tenant, they're the purchaser of either servers on the disk side or media, right? They're at an RC organization most of the time. They could be at a large scale project like Atlas. The customers really for us in NESE are just the storage managers, right? So we interact with a very limited number of people and have them kind of in the fold of the kind of what's happening on the administrative side on a day-to-day. And that's who we engage with. And then on the operations side, this is actually just operated by my department. I have 2 FTEs that are part of this. I'm the service owner, and then the business side of it is actually John Goodhue, the executive director of NJHPCC. So we partner together every month, reports, and billing and all this to make it sustainable. And then how we make decisions about the governance is through this committee of people that I showed before. So when it comes to making, we meet quarterly. I provide, updates on where we think we should go with the infrastructure. They approve, any financial changes we're going to make to rates and infrastructure changes and directions that they want to see us to go. So yeah, so that's the Northeast Storage Exchange, and it's a really important component for us on the Harvard side. It backs storage like at FAS Research Computing. It provides backend storage for things we want to do on Harvard Research Data Connect. So at this point, I think we can just open it up to more conversation.
Yeah, thanks, Scott. So I see there's a lot of questions already in the chat, and there's some questions in the call doc as well. So if anyone wants to speak up their question, feel free to unmute and speak up. Otherwise, I can just simply go over the questions that have been posted in the chat or call doc.
So I'll read this one. I don't know, Bill, if yours is directed towards me or if it's directed towards Curt, but about a web interface development, like for user-facing data management and movement of tools. Maybe Curt, you can.
It was for Tiger Data.
Okay, cool.
I can dive in here. So we are developing that user interface with Agile method, which means that we're, that is a little bit behind the development of the storage infrastructure. So it's still modestly more than a pile of sand in Agile terminology. We've gotten it to a read-only place where people can see what they have and they can understand things. The ultimate vision is that people will be able to apply metadata here. We don't imagine people in the short term being able to move their data from there. I think in the long term we should be able to, but in the short to medium term, we're just trying to make it really about the data management piece of it. So controlling who the users are on your project. Everything in Tiger Data is project based. So there's a sponsor for each project. There's a data manager for each project, and then there are users. So the sponsor or data manager can add users to their project and such. That's either too long or too short an answer, but.
And I would say on the Harvard side, there's another library project called Reimagining Discovery that we're kind of waiting. We're at the cusp of trying to decide, like, do we add more requirements for that project to fulfill our broader mission, or do we wait to see where they're going to go in the next year and then do our own separate thing when it comes to a user interface and the discovery layer?
Raminder?
So good, just
Mhm.
web like the web interface you guys are developing, are you planning to keep it open source? Because that's what, like, in our experience, we use Coldfront and Starfish together, and the Coldfront being open source really helped.
Yeah, we do plan to develop in a way that it could be open source. The library team, we've gotten the funding for some of the positions that are part of that library team, but we've embedded them into the library team. So it's really under their standards for development. They do tend to develop everything open source. So right now, as I said, it's modestly more than a pile of sand. So we don't have anything really to open source yet. But as it matures and as we hit some of those, 1.0 and beyond releases of it, then we likely will be able to share it.
Bob?
Yeah, I just have a sort of quick follow-on question. So thank you both. Great to see you all on this. This does cause me to sort of ask another question around and sort of what we're looking at as sort of active or deliberate data management. Has there been sort of discussions around having this sort of be a part of the natural if you will, aging or tiering or research management process, so that someone would tag this folder as raw data, or just sort of imagining how it can evolve into something that is a natural part of the research process and sort of some deliberate, okay, I need to manage my data now, and what are some of the thoughts around those conversations?
So as I said, MediaFlux thinks of data as either in band or out of band. When it's in band, it fully manages the storage. And so MediaFlux could automatically move stuff from the NAS to one of the object stores because of the age of it, because of how recently it's been touched. But our ultimate vision is that we're currently working with researchers on workflows where their data, their primary copy of the data is in Tiger Data, and their job submission scripts would say, go grab this data from Tiger Data, stage it into Scratch on this cluster, do your operations, and then presumably at the end of the script, there might be something to move the data back. But we ultimately would like to be able to say for Scratch, this data hasn't been touched for 2 weeks, and they set the flag that said you can automatically move this. And so it would automatically get moved from out of band in Scratch to in band on Tiger Data. That's a maturity issue. It's we're still fairly early in this process, but workflow management is an important part of this. And then beyond workflow management, lifecycle management. Eventually, stuff might have the first copy on that tape library that we're putting off site. And then to back that up, we'll have to figure out, Glacier or something for the backup of the backup, so to speak.
And it sounds like there hasn't been any sort of domain-specific discussions yet. So, what you see in biology, the time span is very different from what you would see in economics or something along those lines. Okay, yeah,
and
that sounds great.
And that's part of the reason that we chose MediaFlux, because the model for metadata is rich enough that we could have life sciences specific, molecular biology specific, genomic specific. Like we can have schemas that cascade and actually allow those areas to collect the metadata that they want, that then can drive the life cycle management in very specific ways for those disciplines.
Yeah. I'm also thinking about publishing too. The timelines are very, very different in the disciplines too. So
Yes.
Thank you. Thank you.
Yep.
So there are few questions in the call doc. So one of the questions was, Curt, is data on Tiger data equally available from all computing environments, HPC lab servers, personal laptops, etc.? If so, how is identity managed?
So it is not it is not mounted on our compute nodes. So it's mounted. You have to copy it into Scratch for if you're actually going to do large scale computation. For NFS, obviously we need to have that NFS on places where we control the namespace. For SMB, we can basically share it to anyone. So for laptops, whether they're Windows, Mac, or Linux, we can share it via SMB, and then we don't have to worry about the namespace issues.
So I was just going to say, one of the things we've played with, it's not like in any kind of production form, is in Harvard Dataverse, like one of the newer versions of Dataverse allows you to have a remote data store. So the data doesn't have to be stored inside of the collection of data that is in Dataverse. So there is the capability to connect to like a research computing storage environment. And then when you ingest the data into the repository, right, it indexes it, all that, and creates all the metadata around it, and can create a DOI for it if you want. So the reason why that's interesting is that then it could sit in the high performance computing space and still be accessed directly from the computing environment, right? And then it could also be pulled externally if you want.
Yeah, and we had an interesting conversation a couple weeks ago with a faculty member who said, I want to back up my Scratch data into Tiger data. And the Tiger data team said, no, we are not just a backup. And I said, but we should be saying yes, but we have to change the way he's thinking about it. You're going to put your primary copy in Tiger data, and you'll have a working copy on the Scratch in the cluster. And if you need to do synchronization, you can do synchronization at points, but you really need to Scratch is not a primary location for data. And that's part of the culture, is really understanding that Scratch can die at any minute. We've been using GPFS for years, and so we've had some catastrophic failures, but not many. If we were still using PVFS, we would have failures every other week, like back in the. But Scratch, people have to stop thinking of Scratch as a permanent location for the primary copy of their data.
So the next question again is actually, I think for Tiger data, is what kind of user-facing data management and movement tools do you have for self-management?
So eventually for the self-management, we'll have the web user interface, and people will be able to do metadata management and such there. Everything that we're going to be able to do on the web interface, we're also going to have command line that can do the same thing. For data movement, we're using NFS, so rsync and things like that. That is not the fastest way. What we're finding now is the fastest way to move data is with Globus. MediaFlux does also have native tools specifically for GPFS. So we've also been able to get some very, very high bandwidth moves of data using those, but those are less end user type things. Those would be mediated by my team to do. That would be reserved for very large movements where we're helping someone move things en masse.
I think, and then the next question was like, so with respect to your solutions, right? Like, so as Yuan mentioned, there was that discovery phase, then there's the actual design and implementation phase, and then there's that operational phase. So do you have like any timeframes that you could share with, and like maybe the number of FTEs that were associated with each of these phases? at different sites?
Does Harvard want to go first on this one?
Sure. I would just say like on the the typical model is like when we're developing something, we hire somebody external, work with us. We come up with a plan, work with them, do the development. So like any of the interface or the middleware that we do between different sets of tools would be done in that fashion normally. And then we take it on and then we understand it enough to be able to like make additions to it or rehire them for additional phases of it. So that's kind of the stage right now. It's like the planning of what exactly we wanted to get done in the initial phase of development. Because like this thing, it can be very huge, right? So we want to narrow the focus down. Some things also already exist. Like there's connectivity of metadata between DMP tool, RSpace, and Dataverse. We don't have that implemented locally, but that's something that's really straightforward to do. That's just an implementation, as an example.
And I want to just kind of follow up on that. The leadership team, it is still in a planning stage, but definitely we have one thing that we discussed to do for the 6 months, after the discovery phase, which we just get done last December, is to really kind of have a stakeholder engagement and communication plan in place so that we can make sure the whole campus knowing the HRDC, knowing what we are doing, and then from there, as Scott said, we'll plan the development and implementation stage. But that's the first thing we're going to do.
And I would also say, like, as all of us on the call are facing interesting budget times in a university space, we're trying to be cautious about the way in which we communicate some big, grandiose, new sounding project. I think we're now thinking about like we want to get very specific use cases from very specific schools and onboard just 1 or 2 schools to do something very specific, as opposed to thinking about something really big, right? Because if we solve that for them, then we can then repeat that and reuse that for similar needs and then kind of carry on. So it'll be a little bit more of a, like, I guess, a strategic, get out the scalpel and do some fine-tuned cutting of what we're going to actually do as opposed to doing something really large. But I would just say like we have a lot of the building blocks, like Northeast Storage Exchange exists, the New England Research Cloud. We have all the different kind of cloud-related tools that are adjacent to it that use that storage. We have research computing that each of the research computing places uses Starfish. So we already have a place that has all the rich metadata about the active data stores. So like I think it's just how we want to piece these things together under the hood will be the lower hanging fruit than the one that is the build a portal that integrates discovery with the library as well as all the different data sets that have been purchased and data sets that are created at the university. I think that's the bigger part.
And then from a Tiger Data perspective, no one's going to want to hear this, but we started planning for this in 2018. So it's been a long time. Of course, COVID was in there. We were really kind of building up the team when COVID hit. COVID actually ended up being a benefit for Tiger Data because we're so cross university. We were trying to meet in person before COVID, and that we were able to have much more frequent meetings during COVID, and now we learned you can meet remotely. But so then we started probably the first was to get funding. We did a very high level design and looked for funding. Funding took us a little bit longer than we expected to get. We got the funding about 3 years ago, I believe, and then had some challenges with hiring staff, right? Because you need someone to be the person to lead this. And so we did a really good search, found someone, and then that ended up not working out. So we had to do another really good search afterwards. So that delayed us by another 6 months to a year. And then it all takes a lot longer than you expect it does. And last spring, summer, we realized that initial estimate that we made for how much it's going to cost, both in terms of hardware and in terms of staffing, was pretty grossly underestimated. So we went back to the senior administration and they're used to doing construction projects. They said, okay, so the implementation bump was here, but it's got a little bit higher and it's been delayed by, so they gave us more money. It was absolutely wonderful. But this time we now have the storage infrastructure pretty much fully in place. Of course, it's going to grow and change over time. And also with both the web user interface and the command line user interface, we don't expect to ever be done. We expect that to be a living service that continually goes to the next version, because the demands of the research community are going to continue to change over time.
Thanks, Curt. So I think we are out of time. So I'd like to thank Curt and Scott and Yuan for taking the time and sharing their solutions. I hope everyone was able to take away something for wherever they are at different levels of their data problem journey. So hopefully this was great, useful. So thanks again, and I will see everyone next week. I believe April 2nd is the next call. So I'll see you all then. Thank you.
Thank you.
Bye.
Bye.
Thanks very much, Curt, Scott, and Yuan.
Thanks.